Thank you and hello everyone. My name is Clotilde. I'm a sales engineer at Cristal Laser. We are a manufacturer of optical components, more precisely of nonlinear crystals, based in Nancy in France. Today I will be presenting our development on LBO crystal and what performance results some of our industrial customers managed to achieve with the help of our products. First, let's start with a quick introduction on Cristal Laser. Cristal Laser is a privately owned company which was founded 30 years ago as a spin-off from the University of Nancy in France. Since our creation in 1990, our path has been one of steady and consistent growth. We are the only European nonlinear crystal manufacturer, and as such, we serve a worldwide market by exporting 80% of our manufacture, mainly dedicated to the laser industry. We are a one-stop shop, which means that we are proud to say that we carry out all steps of manufacturing here at Cristal Laser, from start to finish, from crystal growth to the finished product. Our crystal growth capacity is over 25,000 crystals per year, thanks to our 70 crystal growth stations that we design and manufacture ourselves. We are also exceptionally well equipped with 11 saw and 9 polishing machines, which allow us to polish up to 2,500 pieces at the same time in one polishing run for crystals with a size of 3 by 3 by 10 millimeters. Besides, all pieces of our equipment are backed up to prevent a standstill of our optical shop in case of a breakdown. We also own a top-notch metrology equipment with dedicated laser test benches, and a clean room, which allow us to test and verify the quality throughout all manufacturing process and the inspection of the finished product. That way, we can guarantee to our customer a constant quality and anticipate process drift. Even though the nonlinear market is a niche market, Cristal Laser produces every year more than 10,000 products, and we have more than 130 customers worldwide. We deliver to more than 40 countries around the world, and 3 of our products are currently running on another planet, the planet Mars, by being on board the NASA Curiosity and Perseverance rovers. Our production site of 2,500 meters squares is dedicated to crystal growth, manufacturing, and administration. Now I'm going to present a few of the markets that we serve and our field of application. So the first market we can cite is the medical market, with sectors like ophthalmology for eye surgery or dermatology for tattoo removal. Then we also have the space and defense market that we serve. Our products are embedded on eye-safe laser rangefinders or in target designators, or even in rovers for space mission, as I mentioned before, with Perseverance and Curiosity rovers. Another one of our market is the biophotonics market, with DNA sequencing for application, for example, which has proven very useful in the last few years, cytometry, or even research. Last but not least, one of our main markets is also material processing, which is a very demanding market in terms of performance, in terms of requested reliability of the manufacturer. And in this market, we can find, for example, semiconductor industry, marking, or micro-machining. So that's all for a quick introduction to Cristal Laser and which market we serve. And now I'm going to get into the core of the subject with a little introduction before of what is a LBO crystal, for those of you who may not be familiar with it. So LBO is a nonlinear crystal with properties that make it an outstanding harmonic generator. So it has a broad transparency, which ranges from 160 nanometers to 2,600 nanometers, which makes it a crystal of choice for second harmonic generation, third harmonic generation, and some frequency mixing. LBO also benefits from a small Walkoff angle, which is 13 times lower than BBO, BBO being another type of nonlinear crystal, for type 1 SAG at 1,064 nanometers. LBO also has exceptional power handling properties thanks to its high bulk damage threshold, which is over 110 joule per centimeter square for wavelengths of 1064 nanometers and for a nanosecond pulse. And finally, LBO benefits from a high optical homogeneity, which enable us to cut LBO crystals with aperture up to 100 per 100 millimeter square. Besides, LBO crystals are especially suitable for high-power UV lasers, opening up new perspective for laser industry. But as you may be aware of, getting high-power UV lasers that are stable over time can be quite challenging. There are a few key parameters that we've identified and worked on to improve during the years at Cristal Laser, and which help increase the performance of UV lasers. So I'm going to present those key parameters to you in a few seconds. So one of the first parameters we can talk about is to enhance the lifetime of crystals in UV is the surface quality. The surface finish depends on both the polishing quality and on the surface defects. For the latter, our policy is that no defect should be visible on the ×25 magnification in the 150 watt fiber optic cold source. As for the good polishing quality, a low roughness would be a key parameter as it results in a smooth surface with a low absorption. So you can see here on this slide the roughness measurement for LBO crystal, which was produced by Cristal Laser. And you can see that the roughness here is of 2.8 angstrom RMS. And for UV application, we usually set the bar at 3 angstrom RMS. So a roughness that low allows us to achieve an impressively low surface absorption, which is the other key parameter in enhancing the lifetime of crystals under UV. So here we have a surface absorption for a coated crystal, which is under 3 ppm at 355 nanometer. So the crystal is coated with an anti-reflective coating. So a surface absorption that low is made possible by combining an extremely smooth optical surface with a very low residual absorption in the thin film layers. Besides, at Cristal Laser, we also grow a low absorption crystal with a bulk absorption that is in the range of 1 or 2 ppm per centimeter at a wavelength of 1064 nanometers. This is also very important for the long-term UV operation, because it provides power stability to the laser, as the crystal will not heat up even when generating high UV power. So all those measurements were done at Cristal Laser by using a device which is called a PCI for Photo Thermal Common Path Interferometer, pardon my pronunciation, with a calibration coefficient of 1. So this is a very useful device, and I'm going to present to you a little of how it works. So here's the principle of functioning. There's 2 lasers, one pump laser and one probe laser. So the pump beam, oh sorry, I'm getting a little fast. The pump beam is going to be absorbed by the crystal, which will produce a local heating inside the crystal and cause a refractive index change, because the refractive index is temperature dependent. The probe laser then undergoes a phase distortion, which is measured, and the absorption of the optical material is derived from the recorded phase distortion. With this technique, which is very useful because we can measure both the surface absorption of the coated crystal as well as the bulk absorption. So at Cristal Laser, we have 3 wavelengths available for this device. One in the infrared with a wavelength of 1070 nanometers. Another one in the visible wavelengths with 532 nanometers. And another one in the UV region with 355 nanometers. The precision of this device is better than 1 ppm per centimeter. So to resume a bit the presentation until here, we have seen that the quality of the raw materials, the growth of the crystal, the polishing process are all key parameters in increasing the crystal lifetime under UV light. However, there's still one more parameter that is very important, and that is the thin film coating that is applied on the optical surface. So as I said previously, at Cristal Laser, we manufacture every crystal from start to finish. There is just one step that we use an outside facility for, and this is the thin film coating. So in order to control the quality of all steps, even of the coating, we work in very close collaboration with our vendors. And this is how we developed a coating that is specifically designed for UV application. Here, both the coating deposition method and the coating material will influence the coating behavior when subjected to UV light. So on this slide, you can find the damage curve for LBO, which was coated with this specific design with a double bond coating. So this is a test to measure the laser-induced damage threshold, also called LIDT. And the method used to test the LIDT here was a method called S-on-1 with a S equals 100. The wavelength used here was a 355 nanometer wavelength, so in the UV region. And the result we got was a 16 joule per centimeter square at 6 nanoseconds, which is equivalent to 20 joule per centimeter square at 10 nanoseconds. So this is a really impressive and outstanding result because this is a very high LIDT, especially considering the wavelengths. And this parameter is very important because high LIDT is what prevents a catastrophic failure of the crystal and hence of the whole laser system. Furthermore than the LIDT, we also worked on a dedicated bench to better understand and study the mechanism of degradation of the crystal under UV light. So we developed a bench especially for this kind of application at Cristal Laser. So this is all for the key parameters we've identified and tried to improve through the years to enhance the lifetime of crystals under UV light. And now I'm going to conclude with a presentation of a few results of our industrial customers that they managed to achieve by using our crystals. So for starters, we have the French Atomic Energy Commission, who reached an 80% efficiency of third harmonic generation with a laser of 1053 nanometers to reach a wavelength of 351 nanometers. So you can see here that the efficiency was around 80%. To be precise, it was 76%, sorry. Then we can also talk about the 300 watt of average power reached by the IFSW, which is part of the University of Stuttgart in Germany, with a wavelength of 343 nanometers and a pulse duration of 7 to 8 picoseconds. And last but not least, one of our industrial customers has achieved a lifetime above 10,000 hours on one single spot with our third harmonic LBO crystals in the femtosecond laser. So as you can see, those results are already pretty impressive and exciting, but at Cristal Laser, we believe that the development of reliable and long-lasting optics for UV lasers will enable all kinds of exciting applications in a variety of sectors, such as the semiconductor industry or even for medical application, which can only use excimer lasers at the moment. That will be all for me. Thank you very much for listening to my presentation, and we look forward to hearing from you. Don't hesitate to contact and reach out to us if you have any question or any inquiry. And I've put my contact details on this slide, so don't hesitate. Thank you very much again, and goodbye.